everybody. It is Mike Levin on Saturday, April 2nd, 2022 at around 3 p.m. and I'm on the road again to see my kid play soccer, and thought I'd talk about some of my latest challenges. Is it personal? Is it professional? Is it maybe a little bit of both? In that, as an SEO, as a search engine optimizer, I do plenty things math, but very little actually myself. I load other people's packages and I apply them and get the output of their function and know that they have some sort of meaning, which I abide by. And so a great example would be inside the Fuzzy Wuzzy. If you pip install Fuzzy Wuzzy, you get a grab bag of things, one of which I believe is the fuzz class, which includes the ratio method, which is just another way of saying function. So you can get the ratio function out of Fuzzy Wuzzy, and so you give it two inputs. You give it two inputs of like, you crawled a website on such and such a day, and then you crawled the website on another such and such a day. You gave it the same input, or you gave it input this two different times, and the input had a little bit of difference. That difference between the first time and the second time is the derivative, the change over time. So, taking the sum of those changes over time is the derivative, and apparently going the opposite way is the integral. These are math things I missed on the first go-around. I was defeated by high school calculus, and when I encountered it again in college, I hated it enough that it was one of the two reasons, Calc 2, Physics 1, that I shook out of the engineering program. And this generally is like a point of pride among professors, as it was stated to me by my friend Danielle, who is a physics grad, and it's oftentimes a point of pride amongst professors how many people shook out or couldn't get it, and as if that was something to be proud of and not a deficiency in them as an instructor. Many of these things are accessible concepts that people of everyday intelligence can just get. A human, just average human, even, you know, on the scale of so-called intelligence, way across that scale. They could all understand calculus if it were instructed and taught better, and if the language surrounding it made more sense, which it kind of does not, to what I would call a hyper-literalist. A hyper-literalist like me. I'm always, you know, reprimanding my kid for over-literally interpreting things. And I'm like, that's exactly what I do with technology stuff. I am very stringent about abiding by API rules. Once a rule is stated and it's being applied to the whatever in front of you, the set of symbols laid out in front of you, you abide by those rules when interpreting those symbols. Now, as it turns out, when you get up to the topic of derivatives, you have to put high school algebra aside. I was taught there was an algebraic order of operations. Here's how things group together. Here's the preferred way in which things are done. And, you know, when two things are next to each other, it's an implied mathematics operation. When you see an X or a Y, it stands for a symbol. There's not really spelled out words, except if it's later on in maybe trigonometry, when there's a function like sine or cosine. And then you'll see some words together as a symbol, but trigonometry and algebra are not so different from each other that you can't get over those grouped letters, because it's always a function with a parenthesis, cosine, open parenthesis, something goes into it, close parenthesis. It's a function very much like in programming, so it's easy to recognize a function in trigonometry as what in Python we would call a callable. So in the Python world, things kind of make sense. It takes a while to get it. Everything has its idiosyncrasies, its nuances, which are very important. The nuances are actually, and the idiosyncrasies are far more important than anyone likes to generally acknowledge, because that's all kind of assumed stuff and everyone gets tired of pointing it out over again. And it dawned on me that a lot of the shorthand notation that is implied in mathematics is very much like the Python context manager. Or in other words, whenever you see with, the word with in Python, it's a strange thing, but it's a different API, just like radically different things like lambda operators for an anonymous function, or list comprehensions, the extra set of square brackets that you throw around a list so that you can do x for x in. These are kind of new API namespaces that are layered into the already existing Python API, and it can become part of the new formal Python API because things like list comprehensions and lambdas, and the latest one is the walrus operator, occupy places in the language syntax that are not already occupied by other things. And thus, the language can be extended forward in a backwards compatible way. But new preferred Pythonic ways of stating things do in fact emerge, because list comprehensions, for example, are full of goodness. They're one-line loop operators, as Danielle put it. And I'm like, yeah, you know, they have a lot in common with lambdas in being quick one-liners to do something often repeatedly to some input. And to give a shorthand, often briefer, conciser notation to something you would otherwise do in some longer, in Python's case, looping for each item in collection kind of way. Multiple lines and more variable names in the picture usually. Not always, but with the context manager, you open a thing, so there's usually something like a file name, and you open it as something, and that as something, as I usually use FH for file handle, but more often I'm using DB for the database connection being open to SQLite that's built in, it represents some API to a usually iterable, steppable object. So all these concepts, when new to people, are very magical or mysterious or inaccessible at very least sounding, but then you explain it. And in Python's case, things are so hyper-literal. If an object is iterable, you can usually find one of the double underscore things listed inside of it when you dir it that's going to represent it being iterable, about you being able to get a length of it, and various other things which usually belong to object-oriented notation, where an object carries around with it a bundle of things it knows how to do, a bundle of subfunctions. Sometimes they're just values you can check, and sometimes they're whole functions you can call with their own input and output, with their own sub-API. That's where you get object name.this, open parenthesis, value gets fed in, close parenthesis, it gets returned a return value. Even just internalizing the fact in coding in general, and Python in particular, that there is such a thing as a return value, and its nature is totally arbitrary. And usually it's a single call, a single return, but there's different APIs even for that. Nothing is sacred. There's yield, the yield operator, so you can call a function and then keep asking it to yield another value. And each time you ask it to yield another value, it returns something. And it's a very common way to do a streaming in Python. You would just keep calling and it'd keep yielding, and that'd go on for as long as necessary to finish out dumping some large, bit stream. It's a way of doing streaming, hand coding streaming, kind of. I don't use yield very much anymore. I ventured into user interface stuff for a little bit, where on the Python side, Python backending it, I was doing a lot of yielding. Those were my early Pipulate days. I have left those days behind because, in a very reductionist way, you're just feeding input to things and you're getting output. Yes, it can be rigged into streaming. Yes, there's plenty of other protocol layers in the OSI or network layer stack or whatever it is, system architecture, use whatever terminology you want. But things sit on top of things, sit on top of things. And there's a few things you can take for granted about them. There is some input to the system and there's some output to the system. The rules of the input and output may vary, the syntax of how you do it, the rhythm and cadence by which it can be done, such that in one form it's streaming, in another form it's, chatty data, and in another form it's large chunks of data, throwing big blocks of data. And these are ways of exchanging information between systems. This concept is universal, truly universal. It's like how radio works, transmitting, perturbances as information over a media, over distance, over time. So things talk to things, and they have interfaces, they have ways of interacting, input and output. And they respond to each other. An object given input can send back output, usually back to the caller, but even that has variations. There can be cascading communications, where when things call things, it does a process and passes it along in another direction to a different thing. So it's not straight back and forth. That's straight back and forth is just one very bottlenecked way of thinking about things. And it is, in fact, how CPUs and registers and memory-bound heaps and stacks work. There's a certain amount of addressable memory. You can do operations to information that's in that addressable memory. Retrieve, do operator, put it back somewhere. And there's a definite local from and to location. Short-term one for really high-speed mathematical operations where the functions live, and slower, usually physically further away ones where it's for long-term storage, where when the power is cut, the information's still there. These concepts of short and long-term memory, well, number one, they're important. You need to know that there is short and long-term memory, and they're treated differently in computers, and even then they have different APIs to get to the memory. And someday they will be united. Someday universal memory will exist where when you kill the power, what was left over in the running program memory comes back instantaneously where it was left off, without it being some sort of perpetual motion machine. There's always some energy in. So some energy always has to go into the system to ensure that when universal memory's power is cut off, there's enough power for one final commit of the freeze here state. Power returns, processing continues, universal memory. Not there yet. There's flash memory, like in thumb drives, and there's SSD memory, like hard drives without a spinning disk. But they're all flip-flops. They're all one of the two types of memory switches that exist. And I shouldn't say memory switch. One of the two types of switches that exist is memory switches. It goes to two different positions. Some energy is required to to make it flip states, but it remembers what state it was on when it was turned off. It usually takes more energy to flip the state of persistent memory, and it heats up when used a lot and wears out over time as if a mechanical part. You can't build the computer's fast processing memory where it has to calculate the sum of areas under a differential if it has to physically throw back and forth these polar magnetic regions in some magnetic substrate. Rather, instead, the other switches are just really quick. You just throw them and they momentarily do their thing and return to their off-state position, and they only keep their on state for as long as power is being applied. So there is persistence over time with the DRAM. I believe that's normally called DRAM. There's a few different, for dynamic RAM, it's changing RAM, dynamic RAM, and the other is SRAM for static RAM. And there's all kinds of variations on these words, by the way, PROMs and EPROMs, and all the variations that you imagine exist to control systems. Everything's a system. Today's modern computers and the software built on them and the platforms built out of them, those are systems and platforms. And every slice of it going down through the stack is also a system and is also some sort of platform. So the stuff I love, tech, is just as guilty of the reusing of labels in their own namespaces as math is when expressing equations. When looking at an equation, it is important to put aside a lot of predisposed notations one carries with one as luggage from high school algebra. High school algebra teaches one way of looking at symbols and numbers and processing them and calculating them with a particular order of operations. There are others. In programming language, most of them tend to represent the algebraic way of thinking, the high school algebra, Algebra 1, Algebra 2 way of thinking, especially in regards to order of operations. So it's easy to get the false belief that there's something fundamental about those order of operations, that there's something primitive or basic in that about rules about the universe. It's not. It's not at all. It's one arbitrary way of looking at numbers and symbols superimposed on the world that produces reliable, consistent results, that's teachable to minds at a certain age and such. However, again, in a programming sense, where Python represents the algebraic way of thinking, Lisp represents another way of thinking. It's worth looking at the Lisp programming language, if for no other reasons than to appreciate that order of operations can change between different programming languages. And you really must, of necessity, think differently. And when you're looking at Lisp code, in your mind, the interpreter that's at work is a Lisp interpreter. And you have to shift to the Lisp interpreter for what you're looking at to make sense. Likewise, when looking at Python, you very much have to shift to the Python interpreter. And there's all kinds of deep, implied knowledge going on. I bring up again the context manager with Open, or as I more frequently use it lately, with SQLDict, a connection to SQLite that is represented with the API of the common standard library Python dictionary superimposed on it. And I understand from a technical perspective that the shell game, the Swaparoo game, can be played so that a SQLite table can be used with just two columns. The first column being a string, so that all the principles of fast hash lookup can be used against a second column, which is a blob or a binary large object, which is arbitrary code. It's anything. It is what some call, I suppose, in the business, serialized into text what once was a binary object in computer memory. So this representation in the computer's memory is through a process in Python, traditionally called pickling, turned into something that can go into a text field. But you can't really call it text. No one would get that. So you have to call it binary. And you're like, oh, I don't want to look at zeros and ones, so we can't really call it binary or a binary. So what's been chosen, what's been settled on in the industry is it's usually large. These things are usually represent video or some large numeric array. So it's a large object. It's a binary large object, colloquially called a blob. So the SQLite dict library, by default, it uses the SQLite component of Python, which is a compiled C-optimized component just with Python APIs, so Python can talk to the SQL engine, which is embedded in much the same way as the regular expression engine. Whenever you import RE, you're importing a very Perl-like regular expression engine. Why does all regular expression, harken back or is reminiscent to Perl or of the Perl dialect? It's because having regular expressions in those early versions of Perl bundled with Linux, probably bundled with the early distros of Linux in no small part because it had a regular expression engine. A lot of chicken and egg stuff here. So early versions, early distros of Linux included Perl because people got tired of writing in Unix script, pure Unix script, or the slightly more complex dialects made for certain shell interpreters. So it's the Unix shell, the command line, with a little bit of features layered on top. So you're writing in a dialect of Unix shell known as Bash. Bash has been sort of embraced as a kind of standard, a kind of sort of standard. That B in Bash for another shell. So it's the Born Again or Berkeley distro or whatever, another shell system to Unix. So it's in a long tradition of people making another interpretation. So this one interpretation of a Unix shell called Bash script has become greatly canonical because it has been embraced by so many distros of Linux, including that released by a company called Canonical, which makes Ubuntu or Ubuntu, if you prefer, version of Linux, which is the blessed one by Microsoft. They were not bought by, but might as well be an arm of Microsoft. When you add the Linux subsystem for Windows, the Windows subsystem for Linux, WSL, when you activate the WSL feature of Windows, you now have a Linux kernel going on. And the version of Linux, because some distro version needs to be chosen, that Microsoft chooses as the default installed from the Microsoft Store, is Ubuntu, usually 20.04. Although I find myself just as frequently on 18.04 or 18.2, I believe, probably 18.2, the long-term service release that is readily available as an LXD, as a Linux container unit. Oh, so many subtopics. Stop me before I sub-reference again. So, even in my videos, I really should have an appreciation for what math is about. Calculus in particular, but math in general, because my references are so open-ended. I do not abide by a very rigid system by how I tie things together. And mathematics has a willingness to just throw away whatever system you're using and load in another interpreter, to load in another Python interpreter, another Lisp interpreter, and math has its own interpreters bundled in that sometimes you have to really grasp quick, because sub-branches, disciplines of math have their own sub-interpreters. Now, honestly, one of the only times that I came to go, okay, I'm understanding math a little bit better, but it hardly seemed like math I'm understanding, were Feynman diagrams, as explained by Richard Feynman, the physicist that was part of the Manhattan Project. Very young, but, you know, had this, you know, honeymooner's Brooklyn accent, real New Yorker, true New Yorker, like a Brooklyn kid, tough guy kid and everything, the way he talked, his view of the world, like a real character out of like the Honeymooners or the Flintstones. And he was one of the world's greatest physicists and, you know, parents of quantum mechanics. So really helped define our world. But was very sympathetic with people who didn't understand math, because it was overly tied to all these numbers, which didn't really represent the pure essence of what was going on with forces and fields, harkening back to Michael Faraday and his work with James Clerk Maxwell in intuiting what was going on with, you know, shapes and energies and forces in the real world that were much more abstract notions than were easily represented by symbols on a surface. It's a problem. I had an interesting discussion or point with, it was actually my wife. I was talking about symbols for things in pi, and how when I said pi is probably spontaneously rediscovered by, it was probably one of the key things about sentience, of life coming to reflect on itself, its existence, its place in the universe, sensing a universe and outer world around it, that there is self and other, and that they are ultimately maybe not such separate things. The unity of it. Oh, wow. So many sub-references. I got some time to work with. I can go there. All right, so one of the notions that occurred to me, and this is a real sub-referencing, so you really have to put everything aside for a moment to appreciate the fact that there's a long naming tradition of self-referential humor in technology in general, but Unix in particular. So one of the first knockoffs of Unix, not really the boot kernel, not the thing that got the hardware running in the first place, but of the command set, like ls for list what's in this directory, and cd for change the directory I'm in, came from a free software foundation called GNU, or that produced software called GNU. They produced GNU software. Now, their logo generally became that animal that is a GNU, something like an ox or a buffalo, an African buffalo. Is that the right way to say it? Not where the deer and the buffalo roam, but more like the, you know, the water buffalo of the Serengeti and stuff. And it has that as a logo, I believe. Maybe it's the other one. I don't know. I'd stop me before I sub-reference again. It stands for GNU is not Unix. The GNU stands for self-referentially GNU is not Unix. And so there is a long tradition of that silly kind of naming convention in Unix, and by association and inheritance, Linux. So Linux is a testament, is, you know, is a reference to the guy who developed it. His name was Linus Torvalds. And in fact, where the Unix name came from is, shall we say, a more endowed version of Unix called Multics for multi-user, but with certain capabilities chopped off, so it is just Unix. Yes, I kid you not, there is this tradition of naming in technology. Everything in some way or another is some stupid double entendre and something to throw you off the trail, such as it were, of what it really is. So that leads me to two notions. I got to remember to get to the second one about why Python is named the way it is. Truly, people will say it's named after Monty Python. Yeah, that's a good story, but where? Okay, but before I tell you that story, I have to tell you this story about what came to mind with Pi and the rise of sentience. The moment you start to reflect on things, you're usually reflecting on a circle, because the way things orbit things in space, sentient life arising is probably going to be around matter like the clumps of which we understand. Maybe anthropomorphic, we may be projecting, it may be, you know, conceited to think, you know, in a pre-Copernicus, pre-Galileo way, that we can place ourselves at the center of the universe, because in a non-fixed frame of reference, every point can be seen as the center of the universe, and life probably isn't that common that each time it pops into existence enough to define such a coordinate system, it is justified in calibrating the universe using its own location as 0, 0, 0, and calibrate everything in reference to it, because you got to start somewhere, and it might as well be where you are. All right, so we get that out of the way. The observable universe is a bubble out and around us, the speed of light returning to us in a lifetime's distance from us. It's a bubble around us, at which we're at the center of it. If we're moving through time and there's hyperspheres, and going out in any direction will get you back where you started, because the universe works that way. We are very much each at the center of our own hypersphere universe, and there's nothing wrong with thinking of things that way, so long as you abide by the golden rule, or actually the perfected golden rule, which states, "Thou shalt not do unto others as you would not have them do unto you." And so long as you're abiding by that rule, and you're living and let live, then you shall do no harm. And you must have the ability to take no shit. Do no harm, take no shit. The universe balances. Such sentient life forms can go on existing for a good long while in a polite neighborhood of such entities, who are unlikely to ever encounter themselves over space and time in the first place. But if and when they do, if some means of travel is possible, like the Star Trek warp drive, then all bets are off. And intergalactic communities probably exist, and it's a Nash equilibrium, keeping everyone from destroying everyone else. And when bad neighbors rise up for the first time and discover themselves, often by surprise, in this galactic neighborhood, they get swat down by the much more capable and been doing it for a while, kids around the block, right? So it's either one way or the other. The question is binary in that sense. If warp drive-like things exist, then a Nash equilibrium exists amongst sentient coexisting species, because probability. And radio silence among many, Dyson sphere, type 2 Kapierski scale, whatever. There's, you know, type 1, type 2, type 3 on the galactic civilization scale, with us not even being type 1, harnessing all the power hitting our planet from the sun. Type 2 would be to harness all the power from your whole sun with a Dyson sphere type thing. And type 3 would be to harness all the power of a galaxy in some sort of, you know, Pangea, you know, super galactic sentient being thing. So those probably exist, right? There's galactic clusters. How many of those galaxies in those galactic clusters are in fact of a sentient life form type? Statistically, yeah, maybe. So I was talking about like imagining things must be there, taking it on faith, and then seeing the proof of it later. There's a lot of that in math, there's a lot of that in science, there's a lot of that in tech. And it's all tricks. And it's all a certain willingness to put aside what you've already learned. And I know that just sounds like empty, hollow words. Oh, yeah, unlearn what you learned. But 99 out of 100 people saying, I'm fine with that, unlearn what you learned, don't really mean that. They're just parroting it back. They don't get it at that deeper level. I am one of those people. I have a blind spot. I am part of the population that doesn't get math. Show me algebra, show me high school algebra, I'm with you. Show me differential or integral calculus. Show me anything with something that the latex, you know, math formatting language would be required to portray. I probably won't understand it. Show me something that Python can express, and I probably will understand it. And so that's a strength, and that is maybe one of my bridges into math, one of my transition gateways into math could be through Python, and in fact, SymPy in particular, a way of representing ratios, like factors, like, you know, rational numbers. It's rational, 1/3. I can understand that ratio, but the way that's expressed as 1/3 is .3333 repeating for infinity. I have deep vibe problems with that. I'm like, well, then the thing that's wrong is the decimal system. One should not be able to get irrational numbers. It's not rational. It's, to my mind, it's a form of mental illness to take .333 repeating forever and to accept that as just an everyday thing. Okay, I'm good with that. So I know that there's the notation of putting .3 with a line over top of it. That means repeating forever. I'm slightly more comfortable with that. I'm entirely more comfortable with maintaining the original fraction, the expression of a ratio of 1/3, literally 1/3. Now that's hard to cram into computers with line editing the way it is, and symbols the way they are. So I will definitely accept 1/3. But if it's a part of a bigger thing, I'm very much going to want open parenthesis 1/3 close parenthesis, so that the order of operations is explicit. My brain requires this. Nothing you show me that has had that removed and assumed is going to be digestible through my overly literal and conditioned for high school algebra mind. It's not going to work out. It will not end well. So I hit this limitation in math the way so many people do. And I'm a Pythonista. I consider myself an above average Pythonista. I readily embrace weird abstractions to get the job done. Case in point, Pandas has .iloc and .loc with open parenthesis, close parenthesis. It's not even square brackets. So it's slice, comma, slice is the spirit of the thing. The people who make the pandas library in Python, which for those not familiar, those who are tuning into me for the first time on this video, in Python I push data around. To push data around in Python, it's convenient to import pandas as PD, so you've got the PD package at your disposal, which is a grab bag of things that's very much like working with SQL tables, for those who know the SQL data processing engine, database API, or for those who know Excel, Microsoft Excel. Quite frankly, a lot of the stuff built into pandas is reminiscent, will make you think of, oh, I know how to do that in Excel. And it has a good deal of Excel-like things and a good deal of SQL-like things. And it's pre-installed with Jupyter Notebook, Anaconda, and a bunch of other things that need to do data manipulation. And while not part of the standard library, is common enough that it kind of might as well sort of be part of the standard library. And because it works on row and column like data, it is important to have a convenient way to take Windows, Blitz, in my old Amiga day, you know, an X and Y coordinate for the upper left range of the picture or the memory, and an X and Y coordinate for the lower right corner of the image or memory location. And then you have that image in memory, and you can treat it as the block of, I got my low power thing, I gotta make sure this keeps going. I'll try and wrap it up quick, because I don't want to switch back to GPS soon. There were different ways to do that in the past through pandas, including the .ix operator for index. .ix has been replaced by .iloc, and there's a standardization occurring, and people are just by habit giving up the old ways and railing around standardizing on this new way. And I would argue that this is going to be very, very, very long running in the Python community, that this kooky abbreviated way of doing slice, comma, slice, and there's colons in there because slice notation uses open square bracket, colon, square, close square bracket. So if you're going to have two of them next to each other, that's an awful lot of square brackets to open and close. So the Python pandas people dropped square brackets in a slice notation where you have to give two slices consistently for the API. Slice, comma, slice. So colon, comma, colon has meaning. It's one of the most difficult things in my whole Python history to come to grips with, that APIs can invent themselves, that the meaning of things like forward slash does not always mean divide. If you, from pathlib, import path, uppercase P, now you can path, uppercase P, open parenthesis, string slash string, or variable name, slash variable name, slash variable name. The slashes between separate strings, the slashes between separate variable names, the intermixing of each, will always and forever represent the path in whatever path your operating system uses. On Windows, it'll be replaced by backslashes. On Unix or Linux-like systems, it'll be replaced by forward slashes. But in your API, you append together path fragments with slash, and it is not divide. In the path operator, which you import from pathlib, you can slash append string fragments or variable names containing strings. You can do what to your eyes would be dividing in other contexts, but you can do it here inside the path function, because the path function has overridden the meaning of slashes when slashes appear inside its parentheses, which can span multiple lines, I'm pretty sure. Square brackets, no, for objects. I gotta double check that. Whether function input. Yeah, I think so, right? Because when function input is receiving long keyworded parameters, keyworded arguments, it can wrap multiple lines. I remember seeing it, especially with a black NB_black. If you're using Jupyter, pip install NB_black, NB-black. I gotta double check that. But you want the black uncompromising code formatter for Jupyter, making all these indent decisions for you, where it's arbitrary, where white space doesn't matter. White space matters, and indents matter in Python, except where they don't. So Python has its ugly bits, just like math. One must accept that math has its ugly bits, much like Python. It's unified under a system, that system being that APIs can reinvent it themselves. But unlike in Python, there doesn't have to be that one parent object that you start with. There doesn't have to be object open parentheses. One must be given facts about initial object. In Python, it must either be a built-in or it's not there, or be a built-in keyword operator, which is much like being a built-in. You know, there's keywords and there's built-in functions. There's functions that are built in, and then there's imperatives, keyword operators like with. It's not really a function. It's a context of executing code. It's shifting execution context. List comprehensions versus lambdas versus defining a function. There's a prevailing order of operations. In Python, most things are explicit, except where they're implicit. They're only implicit where they're explicitly implicit. Python is weird that way. Some might call it the Dutch logic, the Dutch way of thinking. That might sound politically incorrect, but trust me, import this. If you have Jupyter running and you have not imported this, you're missing something. There are ways of solving problems, the one true right way, but it may not be obvious to you unless you're Dutch. And in tech, I've had enough experience with the Dutch and the Scandinavians in general. Benelux, Belgium, Luxembourg, the Netherlands, and honorary Denmark, Finland, because while not, I gotta get it all straight in my mind. It's a little bit fuzzy, but it's not all Scandinavian. There's other countries, I think Dutch, which is far more south and part of proper Europe, but is often thought of in that context. And I find they share a technology sensibility which is most often right, according to the 80-20 rule, that does not dive excessively deep down the wrong rabbit holes as many languages do and get too hung up on the features while some edge cases need in abundance today, namely concurrency, to a lesser degree object-orientedness, as much as they need a very clear procedural way of doing this. Procedural is funny. Procedural is the way I think, for sure. Procedural is the most natural state in Python. Python supports different mental models for processing, for computing, different styles of computing. The most, digestible to stupid people like me is procedural. One is tempted to call it functional, but that's something different, right? We'll get to functional in a moment. But in the procedural way of thinking, it's the real black box functions. A function has a name, And the way to get data into a function is with open parenthesis, put input inside that parenthesis, and then to close that parenthesis around it again. That is input to a function. And in Python, you define functions with a def keyword, def space, the name you're going to use later on to represent a function that will be able to receive input. And underneath the def, you indent a consistent amount of lines, and all those blocks of code are grouped with that definition, with that it's part of the function. And then it explicitly returns a value, and whatever is returned is the output of that function. And that is procedural programming for the most part. You call functions and you give them input and you get output, and you're like, what possibly different could there even be than that? And this again is parallels with math. I'm coming to understand that there's these complete shifts in ways of thinking that I'm familiar with in coding. You know, Danielle tells me I get it in coding. I shift these ways of thinking. And this is what's required in math as well. And then I make the point, well, you know, I wouldn't really even be coding if it weren't for Python. Many languages have driven me away. I'd rather not code than express myself in this mentally convoluted way required by this programming language. This is why nobody programs in pure Lisp. For real, because you can't build everything up from scratch. Some things have to be pre-built for you, pre-baked. And so what's pre-baked in dialects of Lisp is usually I don't know what they are. You know, it's built up from S functions, but it's Common Lisp. That's one of the standard Lisps that people begin with. And often, just as frequently, Scheme. Scheme is a dialect of Lisp that ruled the computer science departments across the world for a while before they discovered Java. And then Java ruled across the computer science departments of the world for a while. And now they're in another shift. They are more embracing of Python. And so Python is becoming universally accepted. It's one of the accelerators that people are noticing. It's like, how in the world could Python still be growing in popularity? It goes against all, on the surface, reason. You know, surface reason saying, honestly, JavaScript seems like a more logical way to go these days, because you learn one concurrency-friendly, one non-blocking I/O-friendly way of doing things that lends itself very well to the web, which happens to be quite popular. And it also lends itself very well to the server that should be sending responses back to requesting browser things. Again, a web-centric way of looking at things in a non-blocking way that is very reminiscent of the way the browser itself has to work to keep taking input from a user to not become unresponsive. Web browsers need non-blocking I/O, concurrent behavior, where input can continue to occur even while prior input is being processed. Concurrency, non-blocking input. JavaScript, its primary API, is friendly towards that, but in order to be a viable, robust language for the challenges that system builders have today, it is aggressively advanced by the governing body of the language, ECMA, or one of the European standard organizations, of which, you know, many vendors and organizations are a part of. They help invent the JavaScript language. And they get such operators as arrow key functions for anonymous functions, for defining functions on the fly, for feeding functions as input, as argument, parameter input to other functions. You frequently use an anonymous function. In Python, these things can't even line wrap. In Python, these things are called lambda functions, and unlike list comprehensions, which are similar loop or, you know, on-the-fly function things, List comprehensions can wrap because of the square bracket rules or the bracket rules. Lambda functions, anonymous functions, cannot line wrap, which is profound in how Python is saying, it's an opinion, it's deeply rooted, it's a strongly expressed opinion that while Python supports the functional way of programming, where everything is side effect list anonymous functions, you have to cram every such breadth of expressing yourself into a one-liner. Shows you what Guido van Rossum thinks of true functional programming. It's nice to sprinkle it in. Lambdas have their places here and there, but they have their places here and there to the limit of what you can put on one line. And by the way, PEP8 one line should be only 80 characters long, so what could you ever express in a lambda? Python, right? That's Python for you. So it's got its ugly parts. It's got its arbitrary parts, its APIs that are layered in unexpected, strange ways to important effects. And in Python, it all fits together like a jigsaw puzzle that fits with no namespaces violating each other. The namespace of list comprehensions does not stomp on the namespace of the context manager, nor the namespace of the walrus operator, tertiary operators. There's a bunch of different weird APIs layered into Python that perfectly coexist. 100% continuity, all right? There are some weird edge cases about the way bools return binaries versus testing for truth with the double equals operator against true or against false. Certain surprises regarding the -1 index of the find operator, the find method of a string. Strings have the find method. If it's not found, it returns a -1. That -1 of the find returns false, even though -1, because not a non-zero value, in all other cases returns true. Python. So there are and Danielle encountered that one. She actually was like, well, if what you're showing me is true, then the way you're filtering this list to not show things where that underscore doesn't match on the internals of the dunders, that should actually be returning the dunders. I'm like, you're right. List comprehension X for X in, where X.find underscore, should not be a filter to just the publics inside a dir operator, the dir object. It should also return the underscores, because it would return when -1 is it's not consistent with what the bool operator shows you of what a -1 value is truth-wise. So Python has some edge case inconsistencies. It's not 100% consistent. I have to correct what I'm saying, because I think back to my experiences and go, no, we found the little curly cues, the little funny little exceptions and stuff that are opinionatedly sprinkled into Python that one must get used to and accept and abide by, unless you're overriding that behavior with your own API, the way Pandas does. So math. There is a certain amount of suspended disbelief required in the APIs of math. A lot, as Danielle puts it, is being swept under the carpet because assumptions, because boredom, because fatigue of writing it explicitly all the way down time and time again. So just like as with the in the context of an operator of Python, they use a shorthand notation in math that you just have to know from looking at it a lot. And the biggest enemy I find, the very biggest enemy, seems to be predisposition from high school algebra. In the very same way that there is heavy predisposition to the first programming language you formally learned. So there is some article out there that's some programmer, blogger who expressed the opinion that Visual Basic causes, irreversible mental damage to you by being the first programming language you learn. That you will never be able to unlearn the bad habits instilled into your mind by the seemingly logical rules of the basic programming language, which in truth are anything but logical and completely well thought out. Mostly because of good memory management principles. You can't just go to line. The ability to just jump around in execution creates an open-endedness, a reference nightmare that gobbles up your computer's memory, never deallocates memory once used, and creates not good software, unstable software. So, so what? So enter lots of different languages to the picture that had certain strengths, certain weaknesses, certain things for which they were best at doing because they were invented to solve that problem. There's very interesting languages out there that are under-recognized, but are never going away because they're so well suited for the domain in which they solve a problem. Erlang springs to mind. I know almost nothing about Erlang, but in a similar way to a type of old-fashioned computer called VAXes could cluster and cover for each other and be simultaneous running, because these things are deterministic, same input, same output. So you could have multiple ones together that were doing the exact same thing. They were running the same code side by side in a cluster so that one could go down and the computing continues, and you could swap out nodes in your VAX clusters. Well, you needed programming languages that worked the same way, that didn't care where software was running at all. It had this completely abstracted notion so long as there was continuity maintained. And the Erlang programming language is that. The Erlang programming language allows code to continue to run while other tasks running the same code can spring into existence around it and cover for each other, so that old systems can be brought online while new old systems can be taken offline while new systems online. Code being updated, updating and patching running code without restarts. That kind of stuff is possible. It's all just a question of execution context. How is your code running? On what hardware? With what software? With what, abstract control concepts running the show? And so there are very different ones out there than Python. And I know I am very pigeonholed in a way of thinking. I'm actually promoting the pigeonholing. Because the opposite of this flexible, highly flexible, open-minded thinking, embracing of different systems all the time, is an actual very selective thinking about what tools you take up. Because every one of these APIs is a tool with its own complexity and nuance that's hard to pick for certain type of people. My type of mind has a difficult time adapting to the differences from tool to tool, the nuances. I like making discoveries like list comprehensions and context manager in Python. I consider that a deep and a meaningful gift in expanding my capabilities. But I am just as grateful to Python for doing it through non colliding namespace parts of the language. I'm like, oh, you do that over here, and everything else I know still applies exactly well. I'm learning that the derivative works like that whenever you see an otherwise algebraic function. So most of the rules of algebra are mostly applying. But if, usually to the lower right, you see something with a D in it, that D is not algebraic in nature, but instead is like derivative of. You have to think the word derivative, and then the thing that follows is a character pointing back to somewhere in the algebraic looking notation saying that value there is going to be whatever value it's fed, whatever value is plugged into R for the radius of this function is going to also be chopped into smaller bits in units of whatever is next to D. Derivative of whatever value goes in for this D, for whatever value goes in for derivative. This is what I'm trying to, this is the hurdle I'm trying to climb. This is the API blind spot I'm trying to get over. It's not a blind spot, it's a trigger. I get angry because it's not the algebraic notation I learned and was taught as times D. That's dr. So you take, what's on the left, which, you're multiplying those parts together, 2 pi r. So you multiply it by the value of D, and you multiply that by the value of r again. How is it not that? That's algebra. So the certain stubbornness and closed-mindedness that I encounter there is a neopinephrine rush. I get triggered. It's anger over tool inconsistency. And I can never get past 2 pi r dr. But I have to. I have to be Charlie Brown. I have to land flat on my back repeatedly to do math. And eventually I will overcome my deeply ingrained instincts that D must be another variable name and R another instance of multiplying by the value given R over to the left. It's not. Because it's on the right, because it's got a D in front of it, it's derivative R, so you take the derivatives. It is a process being expressed. All math is a process being expressed. This is a different, more sampling, like a digital sampling. It's like, how you get to the digital world, right? Calculus helped lead to digital because of sampling, and you could, I don't know, maybe I'm rambling now, but there seems to be a sampling process where the variable of the sampling distance is thought to go to infinity, which spikes the accuracy of the measurement of an area under a line, which has a very traditional way of calculating it. Because, width times height is, the area of a rectangle. So divided by 2, because you're cutting it in half with that line across it, is the area of a rectangle. So dividing by 2 to get the area of a rectangle, I'm cool with that. Width times height to get the area, dividing by 2 to get the area of a triangle. I've been saying rectangle, but to get the area of a triangle, you take the area of the rectangle and you divide by 2. That's what I was trying to express there. That my feeble little mind can grasp. Width times height for the rectangle, divided by 2 for the triangle. Area under a slope is calculatable. The fact that area under a slope is calculatable and is able to be expressed by this D for derivative next to an algebra equation, I'm a little less cool with. But I'm getting cooler with it. And maybe in not too long, I will be able to do the maths that these people that I look at and go, they're a wizard of another order are doing. That ability should not be exclusively within their realm. I want that for myself. I want to be able to think in math. And thinking in math means a broader framework than I used to think. So anyway, that's where I'll wrap it up. Math has been on my mind. And I am determined now to use Python as a transition language to get to math. Because I can take samples of a thing. I can express derivatives as Python process. Probably loops and list comprehensions, I would imagine. But I can do that. And then I can map that in my mind to arbitrary invoking of such concepts based on the position of things. And it's not arbitrary because the position and the symbols being used are keys in much the way lambda. I've had difficulty with lambda in Python because I thought lambda was some special word. It's not. It could have just as easily and probably should have been foo, right? You know, foo for non-misfunction. That would have been a great inside joke. Anyhow, this is where I wrap up. Thanks for joining me. Hope to see you again soon. And yeah, don't forget to subscribe and give me any feedback you want on learning math if you did it and have some inside tips. Give them to me.